Ordinarily, one might expect to see equations, inequalities, and algebraic expressions in question 1. Take note of the mark allocation to the right of each question. The use of the word to is redundant since we've already seen this in the instructions and information page. The phrase decimal places refers to the fact that we might need to rely on the quadratic formula for solving any of the problems at hand. This formula should be well established within memory and readily available when solving problems. The mark allocation for question 1.1.1 is indicative that this problem is solvable by inspection. First, write this equation in standard form so that we may apply the zero product law. When solving higher degree polynomial equations, we are interested in its linear factors. A neat algorithm allows us to inspect the constant and coefficient terms in the quadratic equation to determine its linear factors. We then solve the linear factors independently to obtain the solution of the quadratic equation. To best arrive at a solution for problem 1.1.2, we rewrite the equation by reversing the order of the expression in the brackets, then cancelling out the negative signs. We obtain the equation. Distributing x and transposing 3, we arrive at the standard form of the quadratic equation so that we may apply the zero product law. With due exercise and experience, one should notice that this quadratic equation is not easily solvable by inspection. So we would, in this case, rely on the quadratic formula, which promises solutions of this form. Our task now is to identify their coefficients and assign the parameters a, b, and c. By substitution, we easily verify the solutions to be 3 plus square root 21 over 2, or 3 minus of square root 21 over 2, which is then left to two decimal places as 3.79 or minus 0.79. When dealing with inequalities involving higher order powers of x, I utilize a combination of techniques. We start by treating this inequality as we would a normal quadratic equation and write it in a sort of standard form. We follow the algorithm to factorize this quadratic expression in two linear factors. From this point forward, I will interpret the solution graphically by assigning labels to the expressions at hand, plotting them on the same set of axes, using the straight line intercepts as domain endpoints. We may inspect the truth value of this expression under the product of signs on each domain. We are clearly interested in the case where the signs are the same. So our solution is given whenever x is greater than 1 or x is less than negative 3 over 2.